Ultrasound reflects at boundaries between objects with different acoustic impedances. That's what makes it so useful for ultrasonic imaging and distance measurement. In this tutorial, we're going to run a time-domain pulse echo simulation where an ultrasound pulse propagates through water, hits a solid cube, and bounces back. Open New Model in Model Wizard, select 3D, proceed to Physics. Under Acoustics, expand the Pressure Acoustics branch and select Pressure Acoustics, Transient. Click Add to move it into the Added Physics Interfaces list. The dependent variable is acoustic pressure in pascals. Select Time Dependent from the General Studies list. Click Done to generate the model tree with Pressure Acoustics, Transient, and the time-dependent solver already wired together. Click Geometry 1 in the Model Builder. Open the Length Unit dropdown and select Micrometer, so all subsequent geometry inputs are in micrometers. Select Parameters 1 under Global Definitions. The empty table is ready to receive the model parameters that will drive geometry dimensions and physics inputs. In the name column, type acoustic medium T, then enter 8 mm as the expression. This sets the acoustic medium thickness to 8 mm. Add a second row, name it acoustic medium L, and set the expression to 1 meter, giving the medium lateral dimension. Add pressure source with expression 120 micrometers. This parameter defines the transducer source diameter at 120 micrometers. Add target size and set it to 500 micrometers, defining the side length of the reflective target block at 500 micrometers. Add the final parameter target Z with expression 7 mm. This positions the target 7 mm along the propagation axis. All 5 parameters are now defined. Under Component 1 Definitions, open the Functions menu and select Analytic to create a time-dependent pressure source waveform. In the Analytic settings, change the function name to pin and set the argument to T. This represents the pressure as a function of time. Enter the expression. This creates a 4 MHz sinusoidal pressure pulse of 1 kPa amplitude, windowed to 500 nanoseconds. The function plot confirms the waveform shape. In the Plot Parameter section, set the upper limit for T to 2e6 seconds. The updated plot confirms the pulse fires during the first 500 nanoseconds and is 0 beyond that. Select Geometry 1, then add a work plane. Keep the default XY plane orientation at Z equals 0 micrometers. Inside the work plane, add a rectangle. Set both width and height to acoustic medium L, then change the base to center. Label the object substrate. Add a circle, set the radius to pressure source divided by 2, and position the center at xw equals -200 μm. Label it transmitter. Duplicate the transmitter circle via the context menu. Change XW to positive 200 micrometer and rename it receiver. The 2D view now shows both transducer elements flanking the center. Right-click the plane geometry and choose Extrude. Set the extrusion distance to acoustic medium T. The 3D geometry now shows the full 8 mm deep acoustic cavity with the 2 transducer circles embedded in the base. Add a block from the geometry menu. Set width, depth, and height all to target size. Change base to center, set X and Y to 0, and set Z to target Z. Label it Target Object. This places the 500 micrometer reflector 7 mm into the medium. Build geometry. Form union merges objects, 6 domains, 44 boundaries. Open the materials node and add water, liquid from the built-in library. Assign it to all domains as the default acoustic propagation medium. Add silica glass from the built-in library. Switch the selection to manual and assign it to domains 3, 4, and 6. The material table confirms a speed of sound of 5,000 per second and density of 2,203 kilograms per cubic meter. Under pressure acoustics, transient, add a pressure boundary condition. Select boundary 8, which is the transmitter face, and set the pressure value to pressure in to drive the transducer with the defined pulse waveform. From the Physics menu, open Radiation Conditions and add Plane Wave Radiation. In the boundary selection, manually add boundaries 1, 2, 4, 5, and 9, which are the outer faces of the Click Compute. Under the Acoustic Pressure Results group, add a slice plot. Set the expression to actd.pt and choose ZX planes with one plane. Set the manual color range from -50 to 50 PA to resolve the wave features clearly. Under Export, add Animation 1. Set the subject to the Acoustic Pressure Result group, sequence type to Stored Solutions, loop over time with 100 frames, and repeat forever at 0.5 seconds per frame. Play the animation. The pressure pulse launches from the transmitter face, propagates through the water column, reflects off the silica glass target at 7 mm, and returns as an echo toward the receiver. The full round trip is captured within the 20 microsecond window. Under Results, expand derived values and add a surface average. Set the dataset to Study 1 Solution 1 with all time steps, select Manual Mode, and pick Boundary 29, the receiver face. In the Expressions table, enter P with units Pascal. Click Evaluate. Table 1 populates time-resolved acoustic pressure. Add 1D plot group with table graph. Time trace shows transmitted burst, echo return at 9 to 10 microseconds from 7 mm propagation.